Hey everyone, Scoop Scientist here. The atmosphere is so heavy that 1 square centimeter at sea level is experiencing about 1 kilo of force. That's putting 1 liter of water on this little tiny piece of paper here. It's also the equivalent of about 14.7 pounds per square inch. Now that's quite a lot of force, quite a lot of pressure. And now the reason why we don't really feel that is because there's the same amount of pressure inside us pushing back out, so it's actually at an equilibrium, so we're not feeling any of the crushing force. But what happens if we were to take the pressure that's in us pushing back out the atmosphere away? Well, I can demonstrate that with some cans, so let's do it. Yeah, look at that. So this is hot. I'm getting ready for that. This has just a little bit of water in it. I'll just tip out most of it. See, I put a little bit in and then give it a bit of a shake so there's not much water left in there, just a few little drops. And then I've got my hot plate here ready. So I put the can on top of it and then wait for any water in there to heat up. It's going to create a lot of steam, a lot of water vapor that's going to fill up the can. And then over here is a little bowl of cold water. And so then, when this heats up, I can flip the can upside down onto the water, onto the cold water here. And what happens is all of the water vapor in there cools down, contracts back into water, creating a lot of empty space in here. And so then the atmosphere around, suddenly the weight of it, it's no longer an equilibrium pushing back out, keeping the can in shape. So you're going to see it crush it. Here's one that I did for a test earlier. Now I have seen cans. I actually did this experiment a long time ago, and one can got almost obliterated. Wow. Alright, so now I figured out how to do that. But this can here is a demonstration of the atmosphere pushing and crushing this can. So this is actually pretty much ready. We're about to see it. So let me move the camera over here. You ready? Awesome. And you can see that as well. It always sucks up a lot of water. Do you see how quick that happens? Now I am filming this at 120 frames a second, so hopefully this will look pretty cool. I've got a bigger can here. Yeah, so while that one's heating up, these are the, I don't know if you've seen them yet, but the limited edition Oreo and Coke. It's fizzy cookie flavored, and Oreo has a Coca-Cola flavored biscuit, which is quite odd. I saw them in the store and I had to get it. I had to just try them out. Yeah, you can hear the water boiling. Lots of steam. So steam coming out the top is a sign that it's pretty much ready to go. You ready? 3, 2, 1, let's do it. Wow. Perhaps the bigger cans, maybe it's to do with the greater surface area, I'm not too sure, but they tend to crush a lot better than these ones. Okay, so I've got some more of these ones. I've put a little bit more water in this one than usual. I didn't shake it out as much. If you listen there's actually at least a decent amount. So I'm curious to see if that'll make a difference. Yeah, the cans do get quite hot. Wow, it's so loud. Yeah, this one, okay, look at that actually. This one crushed way more. Originally I'm thinking it might be because there's more water vapor in there, but I think if there's more water vapor then there's less of a vacuum. So I don't actually, it could just be a fluke by chance, because sometimes this doesn't necessarily work too well. Well, I've got 2 more cans, so. Wow. That was amazing. So much force, and that's the atmosphere that I'm standing in right now that's doing that to this can so quickly. You know what, I think this camera can go up to 240 frames at a lower resolution. For the last one, I'm gonna try that. Alright, I've got this camera here set to 1080p, 240 frames per second. I hope this is a good one. Alright, I'm gonna do it. So quick. Wow. Oh, I'm excited to see what that looks like in slow-mo when I get to edit this. Yeah, okay, so it looks like putting a little bit more water. These ones were a splash and then really shook them out. And they crushed, but not as much as these ones with more water in them. Including this one here, this bigger can. So how does this actually work? You've probably already worked it out because I've sort of told you and demonstrated what's happening, but I figured I should still consolidate it a bit. So with the can being in its pre-crushed state, it has an opening at the top, and so air is free to flow in and out, which means the pressure inside the can is equal to the pressure outside the can, so nothing's going to happen. So when I put a little bit of water in the can and put it here on the hot plate, it expands, filling the can with the gas form of water, with water vapor. And so then when I flip it over onto the cold bowl of water here, blocking the only entrance for any other air to come into the can, what then happens is the water vapor hits the cold water, cools down back into liquid form, creating a lot of empty space inside here. And so the pressure is no longer equal. The pressure inside the can is much, much, much less than what is outside the can. Therefore, the weight of the air just crushes the can, and it happens almost instantaneously, which is really insane to watch. So hopefully with that explanation, this makes sense exactly what's happening, and you can come to realize and appreciate, I guess, how much weight and how heavy the atmosphere around us is, because it's not something you really think about. You think of air as this light thing, which compared to other things, this glove for instance, it does not float with the air, it drops, because this is a lot more dense than the air. But it's quite amazing how this light air around us can cause so much damage so quickly if the pressure is not right, if equilibrium is not there. But anyway, I hope you enjoyed this video. I certainly enjoyed making it. I did make it again. You can check out the old video that I did a long time ago and see what happened then. But in the meantime, if you did enjoy this video, then please give it a big thumbs up and don't forget to subscribe to see future videos like this.